Algorithms are the invisible engines powering our digital world. They shape the way information flows, guide decisions in countless fields, and determine the efficiency and effectiveness of computer programs. But what exactly is an algorithm? And how do these sets of instructions transform data into actionable results? Let's embark on a journey to unravel the mysteries behind algorithms, exploring their origins, their mechanics, and their profound impact on everyday life. An algorithm, at its core, is a step-by-step procedure for solving a problem or accomplishing a task. Imagine you're following a recipe to bake a cake. The recipe lists ingredients, provides instructions, and guides you from preparation to completion. In the same way, algorithms outline a series of logical steps that, when followed, lead to a desired outcome. Whether sorting numbers, searching for information, or encrypting messages, algorithms provide a blueprint for action. The history of algorithms stretches back centuries, well before the advent of modern computers. The term itself is derived from the name of the Persian mathematician Muhammad ibn Musa al-Khwarizmi, who lived in the 9th century. His work in mathematics laid the foundation for systematic problem-solving methods, and over time, his name evolved into the word algorithm. Ancient civilizations used algorithmic processes for tasks such as calculating taxes, predicting the movements of celestial bodies, and constructing architectural marvels. Today, algorithms underpin virtually every aspect of computer science and technology. To understand how algorithms work, consider one of the most basic examples: sorting a list of numbers. Suppose you have a list of unsorted values and need to arrange them from smallest to largest. One common algorithm for this task is called bubble sort. Bubble sort works by repeatedly stepping through the list, comparing adjacent items, and swapping them if they are in the wrong order. This process repeats until the list is sorted. While bubble sort is easy to grasp, it's not the most efficient method for large data sets. A reminder that different algorithms exist for different needs, and choosing the right one matters. Algorithms aren't limited to simple tasks. They're the backbone of complex systems, from search engines to self-driving cars. Search engines like Google use sophisticated algorithms to crawl the web, index pages, and rank results based on relevance. These algorithms evaluate hundreds of factors, such as keywords, site quality, and user behavior, to deliver the most useful information. In finance, algorithms analyze market trends, execute trades in milliseconds, and detect fraud. In healthcare, algorithms assist in diagnosing diseases, optimizing treatment plans, and managing patient data. One of the most influential types of algorithms is the search algorithm. Imagine looking for a specific book in a vast library. A search algorithm helps you find it quickly and efficiently. Computers use search algorithms to locate data within files, databases, and the internet. The binary search algorithm, for example, divides a sorted list in half repeatedly to narrow down the location of the target item, dramatically reducing the number of comparisons required. Another essential category is optimization algorithms. These algorithms aim to find the best solution among many possibilities, often under constraints. For instance, airlines use optimization algorithms to assign crews and schedules in a way that minimizes costs and maximizes efficiency. In logistics, companies rely on algorithms to route delivery trucks, balancing factors like distance, traffic, and delivery windows. Algorithms can also be classified by their approach to problem solving. Deterministic algorithms always produce the same output for a given input, following a predictable path. Randomized algorithms, on the other hand, incorporate elements of randomness, which can be useful in scenarios where uncertainty or variability is inherent. Additionally, recursive algorithms solve problems by breaking them down into smaller, similar subproblems. The classic example is calculating factorials, where the solution for a larger number depends on solutions for smaller numbers. Efficiency is a key consideration in algorithm design. Computer scientists measure efficiency using complexity analysis, which evaluates how the time and resources required by an algorithm scale with the size of the input. The goal is to find algorithms that solve problems quickly, using minimal memory and processing power. The Big O notation is a standard way to express algorithmic efficiency, describing how performance grows as inputs become larger. Sometimes, multiple algorithms can solve the same problem, but some are better suited to particular circumstances. For example, sorting small lists might be faster with simple algorithms, while massive datasets call for more sophisticated techniques. The art of algorithm design involves balancing accuracy, speed, and resource consumption, often requiring deep mathematical insight and creativity. In the age of big data and artificial intelligence, algorithms have taken on even greater significance. Machine learning algorithms enable computers to learn from experience, identifying patterns in data and making predictions. These algorithms power applications like voice recognition, image classification, and recommendation systems. For instance, when you browse a streaming service, algorithms analyze your viewing history and suggest shows you might enjoy, continuously refining their suggestion as they learn more about your preferences. Despite their power, algorithms are not infallible. They depend on the quality and completeness of the data they process. Biased data can lead to biased outcomes, which is why transparency and ethical considerations are paramount in algorithm development. In recent years, there has been growing awareness of the need to audit algorithms, ensuring they operate fairly and responsibly. This is especially important in fields like criminal justice, lending, and recruitment, where algorithmic decisions can profoundly impact lives. Let's delve deeper into a real-world application. Social media platforms. Every time you scroll through your feed, algorithms decide which posts appear, in what order, and from whom. These algorithms consider factors like your interactions, the popularity of posts, and your network. They're designed to keep you engaged, showing you content tailored to your interests. However, they can also create echo chambers, where you're exposed only to viewpoints similar to your own. Understanding how these algorithms work is crucial for navigating the digital landscape thoughtfully. E-commerce platforms use recommendation algorithms to personalize your shopping experience. When you browse for products, the algorithms analyze your past purchases, search history, and even the behavior of similar users. They present items you're likely to buy, increasing sales and customer satisfaction. Behind the scenes, these algorithms rely on complex models, often based on collaborative filtering or deep learning techniques. In navigation and mapping applications, algorithms calculate the fastest routes, taking into account real-time traffic data, road conditions, and user preferences. They weigh multiple variables, updating recommendations as circumstances change. The success of these systems depends on the continuous refinement of their underlying algorithms, integrating new data and learning from past outcomes. Even seemingly simple tasks, like spell checking and auto-correction in word processors, rely on algorithms. These programs compare your input against dictionaries, detect likely errors, and suggest corrections. More advanced algorithms use natural language processing to understand context, ensuring that suggestions make sense within a sentence. Encryption algorithms play a vital role in securing digital communication. When you send a message or make an online purchase, encryption algorithms scramble the data so that only authorized parties can read it. These algorithms use mathematical principles to protect information, making it extremely difficult for hackers to intercept or decode private messages. Advances in encryption are central to cybersecurity, safeguarding everything from personal emails to financial transactions. Algorithms can also be found in the arts and creative industries. Generative algorithms, for example, produce music, art, and even literature by following rules that mimic creative processes. Some algorithms analyze existing works to learn patterns, then create new compositions that reflect those styles. This fusion of art and technology opens new possibilities for expression, collaboration, and innovation. In education, algorithms personalize learning experiences, adapting materials to individual students' needs and progress. Intelligent tutoring systems use algorithms to assess strengths and weaknesses, providing targeted feedback and guidance. This approach helps learners master subjects more effectively, making education more accessible and engaging. Scientific research benefits enormously from algorithms, which process vast amounts of data, simulate experiments, and model complex systems. In fields like genomics, algorithms help decode the human genome, revealing insights into health and disease. In climate science, algorithms analyze weather patterns, predict future conditions, and inform policy decisions. The ability to automate analysis and modeling accelerates discovery and enables scientists to tackle challenges on a global scale. Algorithms are also crucial for robotics and automation. Robots use algorithms to interpret sensory data, make decisions, and execute precise movements. In manufacturing, algorithms optimize assembly lines, improve quality control, and reduce waste. In agriculture, algorithms monitor crop health, predict yields, and manage resources, contributing to sustainable food production. As algorithms become more sophisticated, the need for transparency and accountability grows. Explaining how an algorithm makes decisions, often called algorithmic interpretability, is essential for building trust. Researchers are developing new methods to make algorithms more understandable, allowing users to see why a particular recommendation or decision was made. It's important to recognize that algorithms are tools created by humans. Their effectiveness depends on thoughtful design, rigorous testing, and ongoing improvement. The future of algorithms will be shaped by advances in computing, mathematics, and our understanding of how to solve problems efficiently and ethically. In summary, algorithms are the lifeblood of modern technology. They transform inputs into outputs and guide machines in making decisions and enable us to solve problems at unprecedented scales. Whether powering social networks, protecting digital security, or advancing scientific research, algorithms touch every aspect of our lives. As we continue to innovate, the role of algorithms will only grow, offering new opportunities and challenges for society. By understanding how algorithms work, we can harness their power responsibly, shaping a future where technology serves the greater good. The next time you search online, navigate a city, or receive a personalized recommendation, remember the complex, elegant algorithms working behind the scenes, making the impossible possible.